Hi, I'm Natalie, a rising sophomore at Carlmont High School in California. I recently visited the Department of Chemistry at the University of Washington in Seattle, where I shadowed several students and postdoctoral fellows working in the Nelson Research Lab. Plastics have become a critical threat to our planet that needs to be addressed now. We need a revolution using new sustainable materials to spur large-scale changes. One of the areas that the Nelson Research Lab is working on is finding ways to create biodegradable plastics out of a special protein called bovine serum albumin to address this growing plastic issue. There are two manufacturing processes, additive and subtractive manufacturing. The research group works with additive manufacturing, also known as 3D printing, which is when materials are deposited in layers to form objects. This manufacturing process is much greener than subtractive manufacturing, as it is much less wasteful. Two printers are used in the lab, a material extrusion printer and a vat photopolymerization printer. The material extrusion printer melts thermoplastics into a material that can be shaped and uses the plastic to create 3D printed objects. The vat photopolymerization printer uses a special resin to create objects. When light shines on the resin, polymerization starts, which binds together the molecules in the resin, creating objects. The resin requires several carefully measured ingredients and must be fully mixed before use, so it can take hours to prepare. After 3D printing with the resin, which takes additional hours, the 3D printed object must be dried and cured. The photo-curing process makes sure that the molecules in the 3D printed object have fully bonded. There are several individual projects carried out by the students and postdoctoral fellows. For example, I met with a materials engineer named Ava, who showed me her work in researching how some of the lab's 3D printed materials can be compressed or extended and then returned to their original shape. All of these projects work towards building a better understanding of how the lab can create biodegradable plastics. The group plans on using the biodegradable plastics for medical as well as everyday use. For example, Goche, a molecular engineer, showed me her work with designing stents which can degrade on command. Other examples of what this biodegradable plastic can be used for include screws, wires, and simple structures. I want to thank the Nelson Research Group for taking the time to teach me about their lab work, and I look forward to seeing the breakthroughs they make in the future with their biodegradable plastics.